So even yesterday when we talked about the incline, we said that, oh, we have a surface that is creating a certain angle with the horizontal. And then the object is placed here at the surface of the incline. So let's give some numbers here. Let's say that the angle is 30 degrees with the horizontal, and the mass of the object is 10 kilograms. We'll do one with the mass and the other one with the weight to emphasize what we did on the practice for the equilibrium. So now, what we are assuming, or the first case here, will be a frictionless surface. When we see this this term, that means that the force of friction doesn't exist. Okay, so no friction between the object and the surface. We will evolve into having friction and all that stuff. So now let's convert this into a free body diagram. We'll replace the object of our interest, which is the object with mass 10 kilogram. Oh, by the way, here what we are doing is we are finding what is the magnitude of the acceleration and what is force normal. So we'll start building the free body diagram by replacing the object of our interest with a dot, and then starting from that object, we will throw all the forces that the object is experiencing. So the force of gravity, it's going toward the center of the Earth. The surface that is creating a 30-degree angle with the horizontal. And then since the object is in contact with the surface, then we have force normal, which is always perpendicular to the surface. So force normal. And we don't have any other forces on this situation, because what it is a frictionless surface, and there is no force applied that we can see in the situation. We are assuming here that the object will move on this direction. So this will be the direction of motion. So now, this is the time when we rotate the axis. So normally what we have seen is we have seen the horizontal axis and the vertical axis as normal horizontal and vertical axis, or X and Y axis, that we have seen in math. But what do we do now is we rotate those axes, the horizontal and vertical axis, so that the horizontal axis is along the direction of the motion. So the direction of the motion is along the surface, so then we make a new horizontal axis like this, and then the vertical axis, since you are rotating them, will be this way. On this way, what we are doing is, even though that it seems now that it's a lot of work, why are you doing this? I was just getting used to X and Y axis as a normal X and Y axis, and oh, now you are telling me to rotate them. But actually, it simplifies our work, because what do we do here is we extend the y-axis or the vertical axis, and then we create, so this will be the same angle as the angle with the incline, 30 degrees. And then it's so easy to see the horizontal component and the vertical component of force of gravity. if we are keeping the X and Y axis as normal X and Y axis that we have seen in math or we have seen up to now, what will happen is that we will have a horizontal component and a vertical component of the acceleration, and we will have a horizontal component and a vertical component of force normal. On this way, what we are doing, instead of having 4 quantities to find, what we are doing is we are reducing the number of variables that we are finding by just calculating, because we know what force of gravity is, calculating the new horizontal component and vertical component of force of gravity. Does this make sense? So now, instead of finding the horizontal component and vertical component of the forces, that the object is experiencing with a normal horizontal component and vertical component of the axis, normal X and Y axis that you have seen in math, now we will find the horizontal component and the vertical component of the forces with the new set of axes that we have built in place. The tilted one, the rotated one. Now, since the object is moving from placing there at the top of the incline and then releasing it, then what we will have based on the second law of Newton is the force net will be mass times acceleration. But now by rotating those axes, we will have acceleration only in the horizontal axis, not on the vertical axis. And then now we know that force net is nothing but the vectorial sum of all the forces that the object is experiencing. So then what we do is, since it is a 2D situation, then we construct the table. So we have the new horizontal axis, and we have the new vertical axis, and then we have as a forces, force of gravity and force normal. And since those are the only 2 forces that we are dealing with, the third row will be force net. So now let's take a look at the horizontal component of a force of gravity. So the horizontal component of force of gravity is this vector here. Okay, this is the horizontal component of force of gravity for the new set of axes. Okay, and for the vertical will be this vector here. So this will be the force, the vertical component of force of gravity for the new set of axes that we have in place, that we created by rotating them so that the horizontal axis goes to the direction of the motion, which is the surface of the incline. So now the horizontal component, first of all, is going on the same direction as the new horizontal axis, so is a positive value. And it is whatever Fg is, that is 98.1 newtons, because 10 times 98.1, 9.81 is 98.1, is 98.1 times sine 30 degrees, which is 49.05. You can say 49.1, even 49, it's fine for the purposes of this. And now the vertical component of force of gravity that is going in the opposite direction of the vertical axis that we assign is negative. And since it is the adjacent, will be 98.1 times cosine 30. And it is negative 84.96. And now the horizontal component of force net, if you take a look here, the horizontal component on the new set of axes is equal to 0, and the vertical component of force net in the new set of axes is positive force net. Is this clear? Now, the object with mass 10 kilograms is moving along the horizontal, and it is moving on the positive direction of the new horizontal axis that we have assigned. So this will be the force net on this direction will be 10 times acceleration. And along the vertical axis, the new vertical axis is not moving. It's always moving along the horizontal, not along the vertical. Okay, so you kind of have to tilt your head and then see that it's moving only along the horizontal and not along the vertical. And this is why the acceleration in the new vertical axis is equal to 0. And since the acceleration is equal to 0 based on the second law of Newton, force net on that axis will be equals to 0. So then what we have here is we have two equations. 49.05 plus 0 is equal to 10 times acceleration, and this is equation coming from the new horizontal axis, and negative 84.96 plus force normal is equal to 0. And this is the second equation coming from the new vertical axis. So now, this is math. Let's solve from the first equation, solve for A being 4.91, I will say, meters per second squared. And from the second equation, force normal is equal to 84.96 newtons. Question? Okay, so let's take a look now at a second situation. Now, the incline is the same thing. The incline is in it's kind of flipped. So what we will find on this example, we are dealing again with a frictionless surface. We are finding what is the acceleration, the magnitude of the acceleration, what is the magnitude of force normal, and what is the mass of the object. We'll start with the easiest one, that is the mass, because we have it straightforward there. The weight is equal to the force of gravity and is equal to mass times acceleration due to gravity. And it is given that it is equal to 140 newtons. So from here, mass will be 140 over 9.81. And in your calculator, 140 divided by 9.81 will be 14.3 kilograms if we round it to a certain digit after the decimal point. Okay, so now let's start then constructing the free body diagram. So we'll start with the object of our interest represented by a dot, and then we will draw the force of gravity, which is our weight, and it is equal to 140 newtons. We have a surface that is creating a 32 degrees angle with the horizontal. Perpendicular to the surface, we will have force normal. We are assuming that the object is moving along motion along the surface, and it's kind of intuitive that when you place an object at the top of incline and you let it go, you are not expecting that the object will go up, but will fall down. Then what we do is we construct the new horizontal axis and vertical axis. And as you are here constructing those new set of axes, extend the vertical axis, and the angle that is created with the extension of new vertical axis and the force of gravity is the same angle as the angle of the incline. Is it clear? Okay, good. So now from here, we construct the right angle triangle. And on this way, we create the horizontal component of force of gravity and the vertical component of force of gravity. So this is the horizontal and this is the vertical. Now since we have a 2D situation, what do? Is we add vectors using components. So we have the new horizontal and the new vertical components of force of gravity, force normal, and force net, since those are the only two forces that the object is experiencing. So now, the horizontal component of force of gravity, first of all, is positive. Why? Because it is going on the same direction as the positive new horizontal axis, and will be 140 times sine 32 degrees, which is positive 74.2. The vertical is negative. Why? Because it is going the opposite of the positive new vertical axis that we have assigned. And since it is adjacent, will be equals or 140 times cosine 32. So will be negative 118.73 newtons, but let's leave it 0.7. The horizontal component of force net in the new horizontal axis, or force normal, not force net. Force normal is 0 because it is perpendicular to the to the new horizontal. And then force normal in the vertical axis is the same as, the component of it is the same as the force normal, and it's positive because it's going in the same direction as the positive new vertical axis. Now the object is moving along, as you see here, we are assuming that the object is moving along the new horizontal axis that we assign. So then, since it is moving from rest, means that is accelerating, and that will be mass times acceleration. And on the vertical axis is not moving, so it's not changing the position of the vertical axis, because the vertical axis is or the position of the object along the vertical axis is not changing. So then therefore force net on that direction is equal to 0. And here we have two equations, one from the new horizontal that is positive 74.2 is equal to mass times acceleration, and this is from the new horizontal axis, and the other one is negative 118.7 plus force normal is equal to 0, and this is equation 2 from the new vertical axis. And now, since we know what the mass was, then from equation 1, we can say that 74.2 is equal to 14.3 times acceleration. And from here, acceleration will be 74.2 divided by 14.3 equals to 5.2 meters per second squared. And from equation 2, we find that force normal is equal to 118.7 newtons. Is it clear? Incline that has an angle of 35 degrees and an object with weight of 120 newtons and a coefficient of the friction of 0.10. So when you see this, that means that you are dealing with the force of friction. And we will talk about this in this example. Okay, so you're dealing with force of friction. So when you are drawing the free body diagram of this particular situation, the object of interest will be represented by a dot. So then you have, this is equal to 120 newtons. The surface of the incline is creating a 35-degree angle, and force normal is perpendicular to the surface of the incline. The direction of the motion is going down the incline. Which means that the force of friction is against the direction of the motion. If the direction of the motion is down the incline, the force of friction will be up the incline and will be going like this. So now let's create those new axes. The new horizontal axis is going down the incline. The new vertical axis is going along the force normal. And then the extension of the new vertical axis is creating the same angle as the incline with the force of gravity, 35 degrees. What we are finding on this question is mass, acceleration, force normal, and force of friction. As you notice here, we are just finding the magnitude of them because having the free body diagram gives us all the directions of everything that we need to find. Is it clear? So let's start by constructing the table. We'll have horizontal nu, vertical nu, then we will have force of gravity or weight, force normal, force of friction, and then force net. Okay, so horizontal component of force of gravity will be this vector here, which is found as a sine, so 120 times sine 35 degrees is positive because it's going in the same direction as the horizontal, new horizontal. So will be positive 68.8. The vertical component is this vector here. And will be found by using cosine, since it is the adjacent of angle, and it is negative because it's on the opposite direction of the new positive vertical axis is negative 98.3. Force normal in the horizontal is equal to 0. In the vertical is positive force normal, whatever is the value that we will find. Force of friction in the horizontal is negative because it's in the opposite direction of the positive, so will be negative force of friction. And the vertical component of force of friction in the new vertical axis, new set of axes, is equal to 0. And now force net in the horizontal will be positive, mass times acceleration, and on the vertical will be equals to 0. Now, from the new horizontal, what do we have is 68.8 minus force of friction is equal to mass times acceleration. And this is from the new horizontal. And from the vertical, what do we have is negative 98.3 plus force normal is equal to 0. And this is from the new vertical axis. So now we have a system of linear equations. We'll start solving it, the second one. Why the second one? Because it has one variable on it. So then from here we find that force normal, from this equation, we find that force normal is equal to 98.3 newtons. And now let's deal with the first equation. The first equation is 68.8 minus force of friction is equal to mass times acceleration. When you see this equation, you notice that you have three variables: force of friction, mass, and acceleration. We'll start by solving each of them. So what we have here is that the weight is 120 newtons. So since weight is 120 newtons, we can find mass from here. So mass will be 120 over 9.81. And in your calculator, 120 divided by 9.81 is 12.2 kilograms. So we found mass as 12.2 kilograms. Okay, so now the equation will be 68.8 minus force of friction is equal to 12.2 times acceleration. Still, we cannot find it, we cannot solve it because we have two variables in one equation. However, this is the time where we talk about the force of friction. So force of friction is a force, we said it yesterday, that is against the motion. So it's in the opposite direction of the motion. And the magnitude of force of friction is equal to mu, which is the coefficient of the friction, times force normal. You have this formula in your formula sheet. The coefficient of the friction is a coefficient, no units, that is greater than 0 and less than 1. It never exceeds 1. So a very high coefficient of the friction is when it is close to 1. And a very low or almost frictionless is when it is close to 0. So the coefficient of the friction is a number, a coefficient without units, that it is always less than 1 and greater than 0. So this is telling us that if we know this formula, if we know what is force normal and the coefficient of the friction, we can find what is force of friction. So then, based on our problem, the coefficient of the friction being 0.10 times force normal, that is, we just figured it out here, is 98.3. then the force of friction will be 9.83 newtons. So now this equation, equation 1, will be the same as saying 68.8 minus 9.83 is equal to 12.2 times A. Turning now the equation 1 into one equation and one variable, that is A. So 68.8 minus 9.83 divided by 12.2 will be the acceleration of 4.83 meters per second squared. So now we have everything that the question was asking for. Force normal as 98.3 newtons. Force of friction as 9.83 newtons. Mass as 12.2 and acceleration as 4.83.